Let me show you how to implement exponential search. We start by declaring our bound variable, and we set it to 1. Now, as long as the last item in this range is smaller than the target value, we should double the bound. So while array of bound is less than the target value, we double the bound. So here I'm using the augmented assignment operator. This is exactly like writing bound equals bound times 2. Okay. Now, we don't want to indefinitely double the bound, so we should have a limit here. We want to do this as long as bound is less than array.length. Okay. So after this while loop, we know the range. Now all we have to do is to call our binary search method to do a binary search in this range. So we return binary search. We pass our array, the target value. Now for the left index, we're going to pass bound divided by 2. That's the bound in the previous step. So we pass bound divided by 2. Actually, I would prefer to declare 2 variables for clarity so you can see the code clearly. I declare left and set it to bound divided by 2. Now for right, we're not going to use bound because it is possible that while we double this, it exceeds the length of the array. For example, let's imagine the bound becomes 16, but our array has only 13 elements. So here 16 is not a valid right index that we can pass to our binary search method. We should reduce it to the length of our array. So here I'm going to use math.min. We pick the minimum of bound and array.length minus 1. Because this is the index of the last item in our array. So whichever is smaller, we'll take that as the right index. Now here we pass left and right, and we're done. So this is how we implement exponential search. Now let's test our implementation. So in our main class, we have an empty array. Let's call our exponential search method and search for 1. We get -1, beautiful. What if we add 1 here? We get 0. What if we have 2 numbers and we search for 3? It's still working. What if we search for 5? We don't have that in this array. What if we add a bunch of other items and search for, let's say, 18? Our implementation is still working, so this is how we implement exponential search.